Yet another good application for integration is finding volumes. We'll be doing a lot more of this in third semester calculus. The way that we do it in first semester calculus is take a couple of functions like y equals x squared and another one, y equals x to the fourth. And because both 1 to the squared and 1 to the fourth is equal to 1, they meet on the interval from 0 to 1. So at 0 they meet, and at 1 they meet. And they make this little crescent shape. So take that crescent shape and now rotate it about the x-axis. So spin the x-axis around as if this was a barbecue skewer. So this banana shape is going to go rotating around the x-axis, making something that looks, I don't know, a little bit like a flower vase with the sides going up. Oh, we would need to put it like this so that it could hold flowers. Okay, anyway. So the general way to find volume is that it's pi radius squared, which is an area, and then integrate that. So when you integrate that with respect to x, it's then an area times another dimension, so that creates volume. The only thing is we've got 2 radii. So what we're going to do is imagine when you make, let's say in pottery, and the potter puts a big clump of clay onto the spinning wheel. It's solid. They can then basically cut out the middle part. Well, that's what we're going to do. So the outside part is y equals x squared. So spin that around and find out how much volume is created. Then take the red one, spin that around, find out how much volume is created, and then subtract that out of the x squared volume. Or in other words, we're going to have integrate, and it goes from 0 to 1, and then pi r squared. So the radius is measured from the axis of rotation out to whatever function you're talking about. So this would be the bigger radius. So that's a height of y, and you could integrate y if you want to, but we're going to be using x's. So that means that it is x squared. But then the radius needs to be squared. And then go from here to the smaller one, x to the fourth, find out how much that volume would be, and subtract it out. So the radius is squared. Okay, so this one is x to the fourth. When you integrate that, it becomes x to the fifth over 5. And then evaluate from 0 to 1. This one is, multiply these, it's x to the 8. Integrate that, it's x to the 9 over 9. And then evaluate from 0 to 1. So when you substitute a 1, it's going to become 1/5 of pi. And when you substitute a 0, it's 0. Likewise over here, the only thing that one contributes is 1/9 of pi. So let's see, that's going to be 9 minus 5 is 4/45 of pi. And so if you were to create this vase out of glass or something, this is the volume, the total amount of glass needed to create the artwork.